All right, so bell work day 10. I hope I didn't get that on video. Mr. Seymour is the grandfather to 6 girls. What is the probability of this occurring, that he's the grandfather of 6 girls? And I asked you to make 6 different marks to help you. Okay, so 6 girls. He was the grandfather to 1 baby at one time for the first baby, right? What's the probability that he would, now we're talking probability, so it has to be in fraction form, okay? What are our choices for him being a grandfather? He's going to be a grandfather to this or to that, right? What's the probability? Yes? No, not start off with 6. How many choices do we have of a human being? 2. So the probability that it's going to be a girl for the first grandchild is going to be not 2, but it's got to be a probability. How many successes out of how many outcomes?
1 out of 2.
1 out of 2. 1 out of 2. So the probability of a girl being there as first granddaughter, 1 out of 2. All right, how about the second grandchild? What's the probability of that being a girl? 1 out of 2. And the third? 1 out of 2. And we see a pattern. And what are we doing with all these 1 out of 2 probabilities? We're going to multiply. And if you put this on your calculator, when you have the same factor of 1/2 multiplied by itself 6 times, you could say that's 1/2 to the 6th power. Okay? All right, so if you put that in on your calculator, what are we going to get? Well, first of all, the numerator is going to be a bunch of 1s, right? So that is 1 out of, anybody have it? Maybe you have it as a decimal. No? Nobody's trying this? All right. Well, let's do it the long, old-fashioned way. What is it? 0.015. Anybody else get that? Anybody else try it?
But I need to add the other numbers.
Not add. We're not adding anything.
I know. Wait, tell you the other numbers.
I can't tell what you did. Let me explain.
There's more numbers to it, but
Oh, that's okay. All right, let's do it this way then. What is 2 times 2?
4,
Times 2?
8,
Times 2?
16,
Times 2?
32,
Times 2?
60.
64. So as a probability, it would be 1 out of 64. Jesus, will you take 1 divided by 64 and tell me if you get the same number?
Yeah.
Okay, perfect. So as a probability, we're looking at this. Because each time it came time for him to have this grandchild, there's a 1 out of 2 possibility. Don't you hate it when that happens? Okay. Your face is almost like the color of your hoodie. All right. Mrs. Flight in the front office puts out jelly beans for people to take. Right now, the jar has 7 yellow, 8 orange, 6 red, and 5 green jelly beans. It says, what is the probability of picking a green on the first draw and putting it back, like I said, and then red on the second draw? what do we have to know before I start putting in some of these probabilities?
How many total is it?
How many total? Okay, so let's add them up. We got 7 and 8 is how much? 7 and 8. 15 plus 6. 21 plus 5. 26. So I have a total of 26 jelly beans. So we're looking for probability. That's number of successes out of the total. Well, guess what? We just found the total. So the total, my denominator, is going to be 26. Right? Okay, what's the probability of picking a green on the first draw? How many greens? Yes, we have 5. So the probability of my picking a green would be 5 out of 26. Then whatever we picked for that first one, we're going to put it back in the jar. Not so sanitary. But then how many total will I have before I draw the second one then?
26.
Yeah, I still have 26 because we put that first one back. And for the second draw, I'm looking for how many reds I have. Well, go back in the problem. How many red jelly beans do I have? 6. So multiply those together. Top times top, 5 times 6 is going to be 30. And please, somebody do 26 times 26 because I don't know that off the top of my head. Although I could look at my... 26 times 26.
652.
Really? 26 times 26?
Oh, no. 676.
676. Yeah. Do you know what you did?
I was just trying to do a pick.
Oh, okay. Did you not get one of those yellow calculators? Oh, you got to do that. Makes it so much easier. So the probability, you multiply each of those together and get 30 out of 676. Yes.
Why do we have to multiply them together if they were talking about the same?
They are talking about them separately, but for that second draw, you are going to need to multiply. So if we got a green, let's see if I got some room here. So if I have a green and I have 5, 1, 2, 3, 4, 5, and then I have red. So from drawing a green, if I drew that green, I have 6 choices of getting a red just from that first green jelly bean. If I were to draw it, if I were to select it. So that means each one of these jelly beans, each one of these 5 jelly beans could have a red jelly bean be the next selection. That's just what it means. Okay? Because we've got 5 green, and then once we pick a green, even though we put it back, I have the availability of 6 jelly beans to each one of those green. And since I have 5 of them, that would be 5 times 6. And then out of all of them, there would be 26 times 26 different ways that we could get any particular jelly bean. So a massive amount of possibilities. Okay? Were you thinking we would add them, or what were you thinking?
I was thinking it was 2 different ones. We do 5 and 26 and 26.
Well, we want the probability of them happening back to back. So we're looking at them as one thing together. Okay? That's a good question. All right, any other questions? Okay, let's go now to our notes. And let's go, I believe we are on page 18. What did we talk about yesterday? Does anybody remember? Anyone remember it all? Talked about how you might ask your parents, give or take. No. Given that? Yes, given that. Those are conditional statements. Conditional probability. Okay. All right. So I think it's page 16 on yours. Is that correct? All right. So we're talking about additional probability practice, and, or, and conditional. Now, as I recall, everything is like blacked out on your papers. Is that correct? You cannot see anything, which is really annoying. So here's what I need you to do. Above the first column with numbers, I need you to write lifeboat at the top so you know what it is we're talking about. I know you can see it up here on mine, but you need to write it above your columns so you know what we're talking about. So those are the ones that got in the lifeboat. And then beside it, no lifeboat. Or you could put no LB, as long as you know LB is lifeboat. The last column of numbers is the total. I know, it's really annoying. Very sorry. I don't know why it happened that way. So lifeboat for the first column of numbers, no lifeboat for the second column, and the third column is the total. And over on the far left, the first row of numbers is first class. So you can just put first. Second class for the second row of numbers. Third class. And then we have crew. Jason. You put those in. And then final, we have total for the 1, 2, 3, 4, fifth row. So as you're completing writing those in, it says, on April 15th of 1912, the Titanic, which is a giant ship, I think most of you have heard of it, maybe seen the movie, maybe read the book, sank after tragically striking an iceberg. The two-way table below, that's what they call this, a two-way table, breaks down the passengers that got in lifeboats. So we got first class passengers. Do you guys know what that means? What does that mean? They're at the top. They're the rich people. They had the best accommodations. They had the most money. So they were got the better accommodations, better food, better everything. Second class is maybe middle class. Third class was maybe the lower class. They would be at the bottom of the boat. Their accommodations, their bedding and stuff wouldn't be as good. Then we have the crew and then the total. All right. So we are doing all kinds of different probabilities looking at this two-way table. Okay. So let's really focus in. Let's put the phones away. Let's make sure we're listening and participating. Okay. So, number 1A says, what is the probability of selecting randomly here first class? First class. Put your number down. Don't say it. It is a probability, so it's got to be number of successes over the total. Number of successes over the total. The probability that someone was in first class on this ship, what do you think it is?
325 over 2,201.
That is correct. So first class, we're looking at all people in first class. So you've got to go to the total, which is 325. It is not a conditional statement. There is no vertical line. So I need to put that over my total, which is 2,201. Whoever's got the music on, which could be several of you, somebody's got it on too loud and I can hear it. So turn it down. I still hear it. Somebody over here. Any questions about letter A? All right, let's go to letter B. Says probability of LB. What do you think that means?
Lifeboat.
Probability that someone got on the lifeboat. Write it down. Write it down. What do you think it is? What's the probability that anyone got on the lifeboat? Don't answer yet. Put down your answer. Who haven't I talked to? Desiree, what do you think B is? What's the probability that someone got on the lifeboat? Okay, I love the 2,201. Now, you said 285. How did you pick that? Were you looking over here? Okay, now that would be the total for second class. But we aren't talking about second class. We're talking about somebody who got in the lifeboat. So the lifeboat is the first column. And the total in the first column is, anybody? No. 711. See, here's my lifeboat.
That's the last column.
Yes, you got to go to the total because we're talking about everybody that made it in the lifeboat. How many had that for an answer? 711 over 2201. Raise them high. Come on. I need to see if we're getting this. Ooh. All right. It's hard for me to tell when you guys don't do that. Okay, letter C. First of all, do you see that vertical line? That means it is a conditional. My total is not going to be my denominator. Instead, whatever follows right there is my new denominator. Okay? So those that made it in the lifeboat, what's the total that made it in the lifeboat? 711. That is my new denominator. And now I want to look at all first-class passengers who made it in the lifeboat. So if you remember, this is the probability of first and lifeboat, where they intersect, happening at the same time, all over lifeboat. So the intersection is 203. That's what we learned yesterday, that when you have a conditional statement, you have to have the new denominator. Any questions on that? Jesus, I knew you were absent yesterday. Who else was absent? Desiree, you were absent. Joelle, that's right. That's the new big thing we learned yesterday. So this vertical line says whatever is behind it, that is your new denominator. Okay? All right, so let's go to letter D. What is the probability? Ooh, is that first and lifeboat or is that first or lifeboat? It's and. Looks like an N. First and lifeboat. Lifeboat, not lightboat. First and lifeboat. And means we're looking at an intersection. So find your first. Let me erase this. First class. First class. Up in the sky. Okay. And the lifeboat. So the intersection, my numerator is going to be what? No. Intersection. So it's 203. I've got first class and in the lifeboat. That's 203. Now, is there a conditional statement? Do you see the vertical line? No. So what's my denominator got to be?
1,201.
Very good. 2201, the total. Is this getting really confusing now? Or is it making some sense? Okay. All right, letter E. Let's just talk about the denominator right away, because that should be something you should be able to figure out right away. So letter E, what is my denominator? Oh, shoot. What is my denominator?
2,201.
The denominator, the bottom.
Now that was 2,201.
Right, 2,201. Okay. Now, this is first or lifeboat. That means I need the probability of all first class plus, remember, if it's an or statement, we are for the union. We want as many people as we can get. So the probability of all people on the lifeboat minus the probability of first class and lifeboat at the same time, because we don't want to count those people twice. So what is the probability that someone was in first class? Or what is the number? Let's start with that, because we have the bottom number already. 325, good. Because here's first class. That's everybody that was there. What is the probability that someone was on the lifeboat? Somebody else, give me an answer. Not Jewels, not Bjorn. 711, good. Because that's my total there. And I don't want to count some of these people twice. So minus the probability of lifeboat and first class is going to be this amount right here, which I think is at 203. Yes, 203. So on your calculators, 325 plus 711 minus 203. Jason, come on. What do we get for our total of all of those? Not 508. So you add the two first ones and you subtract the last one. And yes, I got 833. Ladies and gentlemen of this class, you have got to put and try these on your own, okay? Some of you are just waiting for somebody else to give you the answer. You're going to be doing this on Friday's skills check and on our chapter test the following week. You need to be trying these, okay? I'm not trying to be mean. You need to try them to see if you know how to do them, okay? All right, letter F. Well, first of all, any questions about letter E?
Yeah.
Yes, okay.
I don't get how you got the 832.
Okay, do you understand that that is an or statement? Because it's a you. Okay. And in an or statement, you take the probability of all the first ones plus all of the second things that you're looking at, which is, in this case, the lifeboat. So do you understand how I got 325 plus 711? Because 325 is everybody in first class, and 711 is everybody in the lifeboat. So we add those together, but if you look right here where they intersect, I've I have counted those that were in first class and in a lifeboat twice because they were in both groups, right? So I need to subtract that number of people that were in both groups.
So yeah, subtract, so okay.
Correct. Because they were in the group of first class and they were in the group of the lifeboats. And we don't want to count them twice. So that's why I subtract. And if you add 325 plus 711 and subtract 203, that's how we get 833. Okay? All right. Good question. I like questions like that. If you don't understand, you owe it to yourself to ask those questions. Okay? All right. Let's go to letter F. First of all, you tell me what's my denominator. What's the down number? The number on the bottom.
2,200.
That is correct. How do we know it's 2,201? That's the total. There is no vertical line for given that. So it's always going to be that number for the denominator. Did everybody hear me? It's always that number unless you have the vertical line for the given that statement. Okay, is this an or statement or an and statement? It's or. So that means I need the probability of all on the third class, and I want everybody that was part of the crew, and I am going to subtract anybody that was third and the crew at the same time. Now, does that make sense? Okay, so let's take a look. Probability that everyone on the third class got in. Third class right here. Go to the total. 706 plus the probability that someone was part of the crew. Well, crew is right here. That total is 885. And you're like, well, those don't cross. Well, that means there's no intersection. Nobody that was a third class passenger was also part of the crew. So we don't have to subtract anybody from there. You just add those together, 706 plus 885, and you should get what amount? What amount are we getting? Genesis, did you get a total?
191.
Yes. Did you get a total? F. Very good. 1,591. Yes. You were right. Any questions about how I got that? Okay. All right. Letter G. Letter G. What's the probability that someone did not get on the lifeboat given that, oh, there's that given that vertical line, given that they were a third class passenger? What is my denominator here?
706.
Say it one more time.
706.
And what did you say, Juels? No, because there's that given that statement. You are correct, Micah. I know you were absent, and I appreciate that you're trying. But given that they're a third class passenger, that means I go to this total, and that is my denominator, because they have to be a third class passenger. Okay? It's kind of like you see that vertical line, and it goes, so if it's behind the vertical line, it then is going to be on the bottom of your probability. So, no lifeboat and third class passenger, where do they intersect? I can't read what that number is. 528. Yes. So right here is where they cross. So that is 528 out of 706. So that's a pretty high probability that third-class passengers who didn't get on the lifeboat. There was lots of those. Okay? Any questions on G? Somebody's listening to a podcast, music, or something, and I just find that very rude. I wish you would stop. All right, let's take a look at the last one out of this table. Is that an and or an or statement? And. So they both have to happen at the same time. I'm looking at an intersection. So third class and no lifeboat. What is my denominator? That's right, 2201. There is no vertical line, right? So that means I put the total down for my denominator. All right, then third class and no lifeboat. Well, that's just like the last one, but with a different denominator. Third class, no lifeboat is going to be 528. That's the intersection of third class and no lifeboat. Okay. So the probability that you were third class and did not get out of a lifeboat given all the people is a smaller probability than if you were third class and didn't get on a lifeboat, just out of the third class. Yes.
So for or you subtract.
For or, you do subtract what is common to both, where they intersect. Yes. You find the intersection. You don't add them. You look at where they both happen at the same time. So for or, you add each one individually and subtract where they overlap. For and, it's where they overlap. Does that kind of make sense? Okay, good. Any questions about that first part of the table? All right, let's see if we can get these last questions done, and we'll do the next one tomorrow. So it says, which class of passengers had the greatest probability of getting in a lifeboat? Which passengers had the greatest probability of getting in a lifeboat? Let's see. Getting in a lifeboat. All right. Well, let's talk about first class. How would I figure that out?
Which one has the most people in it?
Out of
The total in that column.
total in that column?
Yeah, like all the people in the lifeboat line, which one has the most?
It said, now listen to the question again. Which class of passenger had the greatest probability of getting in a lifeboat?
Do you look at the intersection out of like the total?
Well, what number are you thinking? Let's talk about this. So for first class, what would you do? What do you think you would do?
Find where lifeboat and first class intersect.
Okay, so that gives you the number, right? That gives you the 203. So does everybody see in first class in a lifeboat, that is 203. Okay, first class and a lifeboat. But it says, what class of passenger had the greatest probability? If I'm looking at first class, and this is a little bit different. When I say everything's always over 2201, that's not going to be the case in this one. But for a regular table it should be. But this is a different kind of question. So 203 people from the first class got in a lifeboat. How many did not from first class? 122, right? So if I want to know the greatest probability of getting in a lifeboat, I have to put it over all first class passengers. All first class passengers. So on your calculators, take 203 divided by 325. Because that's how many from first class got in the lifeboat. What do you get? You get point something something.
6246.
0.6246. Okay. So if I change that to a percent, that's like 62%. So 62% of all first class people made it in a lifeboat. All right, let's look at second class. Second class people, how many people made it into a lifeboat? Well, here's second class. Whoops. Second class. Here's my lifeboat. How many made it in? 118. How many were there total? 285. Take 118 divided by 285. What do you get? 0.414. That's 41%. And let's look at third class very quickly. Third class. How many of those made it into the lifeboat? The intersection, 178. Out of how many total third class were there? 706. Boy, you can tell that's going to be lower. And what number is that? 0.252. Change it to a percent. That is 25%. So, first class, 62% made it onto a lifeboat. Second class, 41% made it into a lifeboat. Third class, 25% made it into a lifeboat. So who had the greatest probability? It is the first class. Are we shocked by that? No. No. All right. So there's our story about the Titanic. Good job today. I know it was a lot of number crunching. You still should be looking at working on homework 7-3. Tomorrow, we will finish up this section and review for Friday's skills check. Okay? Please keep working on any late or missing assignments. Talk to me if you want to retake a test. That's the best way to bring your grade up, but you have to have done the homework also. Okay?